Welcome everybody. Today we are going to go over how is it that we can answer questions of application of quadratic functions. So here's our first question. It says Nate launched a model rocket from the top of a building that is 80 feet tall. The rocket has an initial upward speed of 160 feet per second. The path of the rocket can be modeled by the equation h of t equals negative 16t to the second power plus 160t plus 80, where h of t is the total height of the rocket and its t is the time in seconds. Okay, so first of all, full disclosure, we are going to fill our table, which is going to indicate our answers using a table in the graph. So for that, the first thing that I have to say about that is that every single one of your variables t, you're going to have to change them to x in order for your calculator to be able to graph it. Okay, so that's exactly what I'm going to do, and I'm just going to tell you what are the values that I got. So straight from my calculator, I got that at time 0, also our x0, the height was 80. At 1, it was 224. At 2, it was 336. At 3, it was 416. And then 464. Sorry, that's 480. And then we started the bouncing, started going down. 464 in the same order, 416, 336, 224, 80, and negative 96. So in here we're going to use this tool. When we have a table, the way that we can solve more of our questions to get a better idea is actually to look for the bouncing point, which be as we are going to look for the repetition numbers. So for example, here again we're looking only at y values, and then here I have 464 and here I have 464. So this is what I do. And then I say 416 and 416, 336, 336, 224, 224, 80, 80. And in case of something, I mean, we could use this to predict. So if here I have a negative 96, here the next number will be negative 96, not that we have to do it right now. Okay, so there's a few things that we do this for, and the most important one is so we can locate the vertex. Every time that you do your repetitions, the number that is at the center, or the point that is at the center, is going to be your vertex. Okay, so this is my vertex. That's why I know that I need to focus on this number to know if this is going to be a maximum or a minimum. If this is the y value, if you compare it to others, you're going to find that it's the biggest one. That's why you know that this is going to be a maximum. Okay, so now I get an idea about what are the heights. I can start answering my questions. What would be a reasonable domain for this graph? Well, first of all, domain is always talking about x values. And I know that the domain for any, or the x values for any quadratic, could be from negative infinity to positive infinity. But in this case, I know that this is taking off from 0. And I know that since this rocket is, once that it lands on the ground, that's going to be it. Okay? So it'll be a good estimate for me to say that the x values are going to go from 0 all the way. And I can say it is not true. I know that mathematically this is saying that it's negative 96, but that's not true. Once it reaches 0, that's going to be it. So we're just going to say, oh, it's going to be about 10.5. Now, when we talk about range, we talk about the y values. And the y values are actually the height. Now here I can see that the lowest that this can have is going to touch 0 because it's going to touch the ground. So I'm going to say from 0 to what? What is the highest point? 480. Very good. And then I have more specific questions. What is the height of the rocket at 3 seconds? So seconds, 3, 416. What is the height of the rocket at 9 seconds? At 9, 224. When will the rocket reach 336 feet? So many of you are like, oh, 336. But remember, it's going to have this height twice. So I have it here again. So it's going to be at 2 and 8 seconds. So we're going to say 2 and 8 seconds. That will be when it's at that height. At how many seconds will it be at 464 feet in height? So 464 at 4 seconds. But is that it? No, because we also have it at 6 seconds. So 4 and 6 seconds. It has this height twice, so we listed 2 different times. What is the maximum of the path? And they want the ordered pair. So we said that's going to be the vertex, because the vertex is a maximum in this case. So it's going to be 5, 480. Now here they say, what is the maximum height? They want to know only the height, so we list only the height in the vertex in the maximum, which will be 480 feet. When will the rocket reach its maximum height? When is this height going to occur? At 5 seconds. So we're going to say 5 seconds. Will the rocket go higher than 500 feet? So if we are saying that this is the maximum, it's never going to get higher than that. So we are going to say no. Why not? Because the maximum is 480. It's not going to go above that. What is the starting height of the rocket and why? So the starting, it will be at time 0. We have 80. And if that doesn't make sense to you, we need to go back and read. We will notice that it's saying that he is launching the rocket from the top of the building. So it is starting at 80 because it's at the top of the building. Because it's at top of building. In other words, it didn't start from the ground.